All right, PreCalc students, we are on the second half of our summer homework, and we are now in the prerequisite chapter of our book, and this will be section number 1 of that. We have a lot to go over, and I am going to talk really fast, but we have 4 topics basically. Interval notation, which we'll spend a lot of time on. Properties and numbers, we won't spend so much time on that. Exponents, we have already done by the appendix. And then fractions and decimals we'll finish with. This last one should be fairly easy for you, so we won't spend a lot of time with that. But this one right here is where we'll spend most of our time. So let's get right into it. So thinking of interval notation and properties of numbers, we have a trichotomy, and that is for any 2 numbers, we'll call those numbers A and B, but it doesn't matter what they are. So let's say that A is 4 and B is 6. For any 2 numbers, A and B, one of these is true. Well, what is one of these? Well, A could equal B, and in this example, does 4 equal B? No. So it's not that in this case. A could be less than B, which is true in this case. 4 is less than 6, so we got that one. And the third one is A could be greater than B. And in this case, 4 is not greater than 6, so no, we don't have that. But in general, trichotomy, whenever you see that word, that's the property that for any 2 numbers, one of these 3 is true. The numbers could be equal, one is less than the other, or it's greater than the number. Now we always read these, sometimes there's confusion on this symbol right here in this symbol. We always read left to right, so we consider the first number first, and the second number second. So as I look left to right, if I have, say, -10 and 8, and I wanted to compare those numbers, I read left to right. -10 is less than, see, less than, the pointy end is pointing towards the smaller number. And if you were to think of this like a shark, the shark wants to eat the greater number. But just read left to right and you'll be fine. If I flip this around, well, now the 8's on the left. 8 is greater than, bigger than, -10. Read left to right. We would not read this sentence if we had the sentence, the cat is fat. See, we read it left to right. The cat is fat. We wouldn't say fat is cat the. That doesn't make any sense. We read, again, left to right. So don't make these symbols more confusing than they need to be. All right, interval notation. Now, this does look a lot like points, but we aren't talking about points, we're talking about intervals, and that's like the distance or space between any 2 numbers. So like this one right here, it looks like an ordered pair, a point that you would plot, but when we're thinking of intervals, that's not what we mean. We actually mean -3 is less than some number, we'll just call it x, but it can be anything, which is also less than 4. So I'm thinking that x is between -3 and 4, and on a number line it might look something like this. Here's -3, here's 4. Open circle to mean not including, and open circle to mean not including, and between those. So x, or our number that we're talking about, is between -3 and 4. So we see that if we have parentheses, we aren't including, and if we have these braces, we mean including. So on this next one, we mean including -3 and going to -1, but not including -1. So we mean -3 less than or equal to, see I can include it, so I have the equal to symbol, x is less than -1. And on a number line, that's going to look like, well, let's say here's -3, here's -1, include -3, so darken the circle, go all the way over to 1, but open circle because we are not including it. This next one means between 9 and 12. So, but not including the 9, but we are including the 12, so we'd say 9 is less than our number, x or y or whatever, is less than or equal to 12. And notice that when I'm writing it this way, with inequalities, I am using the less than symbols, not the greater than symbols. I'm not writing it 12 greater than or equal to x like this. That way it's backwards. We want the smaller number on the left, the greater number on the right. And on a number line, 9 on the left, 12 on the right. Darken on the 12, open on the 9, and we fill in right there. All right, this one I include both the 7 and 18. See, including. So we'll say 7 is less than or equal to x is less than or equal to 18. And on a number line, still 7, 18, and we'll darken those circles. Now, I'm being kind of sloppy here with my number lines, so you should probably number line them out like on the page that's coming up. All right, when we get these infinities, notice that negative infinity is going to be on the left, and a positive infinity is on the right. So that's meaning that I'm going infinitely in one direction. So it's actually informative to do it on the number line first before going to the inequality. So 7, and I mean going infinitely to the left. Okay, now I include the 7, but I can never include infinity because we never actually get to an infinity. So what is this? Well, x is less than or equal to 7. This one, we'll start on a number line, and I'm going infinitely to the right because infinity is on the right. So I start at my 7. I'm not going to include my 7. I go infinitely to the right because my infinity is on the right. And now x is going to be greater than 7 because it's going bigger. Okay, I suppose you could write it like this: 7 is less than x, and then flip it around, but that's somewhat confusing. All right, here we have negative infinity and positive infinity. So we don't really have a starting point, so I don't know. So we're going both directions. That's all the real numbers. Now we have negative infinity up to negative 12. So here's our negative 12. We are not including the negative 12. And we go infinitely to the left. So like that. So x is less than negative 12, and I don't include the 12 in that. So going between each of these can be kind of confusing, especially with the infinities, because we can never include infinity. Just note that negative infinity will be on the left and positive infinity on the right. So here we are starting with our number line, and let's say I want to write it the other two ways. So this is pretty easy. Negative 10, I don't include that, is less than x, and then is less than equal to 5. Now I don't know why students get this all confused. It's just a sandwich. See, here to here, you know, easy. Drop down that negative 10, drop down that 5, always some less than symbol. And I'm including this one, so I'm including that. X is between those two numbers. There's no reason to make this more difficult than it needs to be, because look, x is between these two things, so drop them down. See, negative 10, 5, and our numbers between those. Don't make these look weird. Don't flip them around. Don't give me a greater than symbol here. That would be wrong. Negative 10 is not greater than 5. That doesn't make any sense. So negative 10, see, I drop that down, is less than our number, whatever it is less than or equal to 5. All right, now I'm going to go ahead and get this in interval notation. Notice I did not include the negative 10. I did include the 5. So parentheses on the negative 10, comma, 5, and then a brace here because I included the 5. All right, here I have negative 5 inclusive to 10 not inclusive. So on a number, well, I already have this on a number line, but as an inequality, negative 5 is less than or equal to our number is less than 10. Easy, see, I dropped it down. This compound inequality should always look something like this. In interval notation, I included the negative 5, comma, went up to 10, not inclusive. Now on this one, neither are included, so negative 5 is less than x is less than 10. And as far as interval notation, negative 5, comma, 10, parentheses on both sides because I don't include either of them. This last one, I include both of them. So in interval notation, negative 10 to 0, include the 0, include both of them. And on inequality, that's going to be negative 10 is less than or equal to our number, is less than or equal to 0. Easy, see, sandwiched between. Now, these are not sandwiches. These are involving infinity. Notice this one is getting infinitely big, so it's going to the positive side, and this one's getting infinitely small. So I'm going to have my infinity on the right, and I never include it on this one. And on this one, I have it on the left, negative infinity, because it's going to the left, and comma. I never include infinities. because I never actually get there. Now on this one, this top one, see, I don't include the 5, so 5, comma, and that's in our interval notation. As an inequality, I would say x is greater than 5, because x is bigger than 5. See, x is getting infinitely big, greater than. This one, now again, you could write this as 5 is less than x. That is okay. We tend to like the variable on the left, so we would flip that around and get this. This one, negative infinity all the way up to negative 5, and we don't include that negative 5. And as an inequality, see, we're getting infinitely small, so we could say that x is less than negative 5, okay, and that's fine. This one we include the negative 10, and again, we're going to negative infinity, so negative infinity on the left and all the way up to negative 10, inclusive of the negative 10, however, because that's a closed circle. And as an inequality, I'm going to say x is less than or equal to negative 10. Right here, I'm going to the right, so that's infinity on the right, positive infinity, and we go to 10 on the left here, that's the smaller end, so including that 10 though. And as an inequality, see, we're going to say 10 is less than x, okay, but flip that around, x is greater than 10, because it's getting infinitely big there. So remember, things on the left, you know, that's going to negative infinity, things on the right to infinity. All right, so in your textbook or on a quiz or something, you might have something like this: express the interval the 2 other ways. So this is inequality symbols. So the other 2 ways would be interval notation. So I don't include the 5, and I do include the 8. So negative 5, comma, 8, and brace the 8 because we include it. And then on a number line, negative 5, 8, and then open circle, close circle, connect. Pretty easy. This one, x is on the left, and notice I had that less than symbol, so it's getting infinitely small. So negative infinity, comma, 4, and I don't include the 4, so like that. And on a number line, we would go to 4, and x is less than, so open circle, just like that. Here we start at 9 and go infinitely big. So we include, the 9, so 9, and we're going to go infinitely big, so x is greater than or equal to that 9, because it's getting bigger. And on a number line, we would show that here's 9, and include the 9, and go to the right because we're getting infinitely big. Sometimes it's easier to go to the number line first on these before trying to write the inequality. These should be easier questions for you, but they are tricky, easy to mess up if you aren't paying attention to what you're doing. So right here, we go infinitely small, but we're going to start at negative 1. So on the number line, will help us out, negative 1. We do include that negative 1. We go to the left because we're getting infinitely small. So that's going to be x is less than or equal to negative 1 because we include that negative 1. This one, we see a sandwich. So 3 is less than or equal to, we include the 3, x is less than 7. And as in interval notation, we brace the 3, go to the 7, and parenthesis the 7, so like that. Here we get infinitely big, so we do start at the 3, and then we include it, and we go all the way to infinity, but we never include an infinity. We never should brace the infinity, because we don't get there. And then we need that in inequality notation, so that's going to be x is greater than or equal to 3, because we do include that 3 and we get infinitely big. Alright, properties of numbers. You should be familiar with these. In a word, the commutative property has to do with the order of our numbers. The associative property has to do with the grouping of our numbers in a word. And the identity property, it really can't word it out, but I'm just going to use the word same, and you'll see why momentarily. 0, we get 0, okay? And the inverse property, we undo something. So let's take a look at what each of these look like. If I have A times B times C, ABC, I could rewrite that as BAC. See, I changed the order. See, the A and B switched their order. In addition, maybe I have something like this. I could change the C and the B on the inside of that parentheses. See, these two switched their order. So basically, if you have all multiplication and you see the order of your numbers different, that's commutative property. If you have all addition and you see the order of your numbers different, that is the commutative property. Associative property has to do with grouping. So if I have all multiplication, but I do have some grouping symbols here. All right, now I actually didn't even change anything there, so let's redo that. See, if I move those parentheses around and I do the A and B first, since this is multiplication, it doesn't matter which group I do first. So I see the parentheses change position. So that's the associative property, and with addition, very similar. And notice the actual order of the numbers in neither of these cases did not change. It's where the parentheses are that changed. And notice that it is, in this first case, all multiplication or all addition. So I would say this first one right here that I'm circling, that is the associative property of multiplication. And this other one would be the associative property of addition. Up here, back to commutative property, see, this is all multiplication. That's the commutative property of multiplication. And this second one right here, that's the commutative property of addition. Because the order changed, down here the grouping. All right, identity, the same. So if I have A plus 0, what would I get? Well, anything plus 0 is that thing. See, I got the same thing out. And if I had A times 1, so I get A. See, I get whatever I start with. I started with an A, I got an A. So I can add 0 or I can multiply 1 by 1. So like if I had 4 plus 0, that equals 4. Identity property. The 0 does nothing to that 4. And 4 times 1. The times 1 does nothing to that 4. So identity property. 0 property. I get 0. Now this has to do with multiplication. A times 0 equals 0. That's going to be 0. These two are confused. The identity property was 0 and the 0 property. If I add 0 to A, I don't get 0. It's when I multiply my number by 0 that I do get 0. So when is this important? Well, when we do factoring, this is important. When we're solving quadratics, this is important. Anything times 0 is 0. So basically that. Inverse property, we're undoing something. So there's a lot of these, but to name a few, if I had A plus negative A, I get 0. See, the plus A and the minus A undo each other. Or A minus A equals 0. Or if I had A times 1 over A, well, the A's cancel, right? So they undo each other and I get a 1. So there are a lot of these inverses, but basically think of inverses as undoing some sort of operation. Okay, I think I was going to do examples of that, but I guess I'm not. I'm going to just jump right on. Product rule. Now we've already done exponents in our appendix, so we won't go over them in detail, too much detail. Our product rule, just to rehash, if I have an x to the A times x to the B, see, these are the bases and they're the same, so I get x to the A plus B. And quotient rule, if I'm dividing, so if I had x to the A over x to the B, notice these bases are the same, that's x to the A minus B. And power rule, if I had x to the A and then to the B, okay, so I'm going to get x to the A times B. I multiply those. If I have a power to a power, I multiply them. And the 0 rule, anything to the 0 power is 1. Please don't mess that up. And our negative rule, so if I had x to the negative n, or whatever our exponent is, I could move that down and have 1 over x to the n. So let's talk about this one a little bit more. What if I had 4 to the negative 1 over 5 to the negative 2? What would I do to actually evaluate that? Well, I'd move this up and it would switch to 5 squared, and I would move this down and it would switch to 4, and I get 25. See, 5 squared is 25 over 4. So not too bad there. There are some other other things that we could do with that. Let's say we get a few of these. And try 1 or 2. There, okay. Let's evaluate that. So this 3 has an exponent of 1, this 2 has an exponent of 1, power to a power. So I have 3 to the negative 2, x to the negative 8, see power to a power, so I multiplied those exponents, all over 2 to the 4th, and x to the negative 12th, I multiply those. So now I can do a few different things here. I can actually move that 3 down, and I'll get 3 squared times 2 to the 4th, and I can move that x to the negative 12th up if I wanted to, and that x to the negative 8 down. That's not a necessary step. Actually, at this step I could subtract them. I'll show you that in a minute. And then right here, quotient rule, so I can subtract those x to the 4th over, now that's 9, that's going to be 16, so whatever 9 times 16 is. Continuing here, sorry for that little interruption. We have 9 times 16, whatever that is, you can use a calculator to figure that out, but 3 squared is 9, 2 to the 4th, 16. And then our x to the 8th, see what we did here is we used our quotient rule on this, x to the 12th over x to the 8th. We subtract those exponents and we get x to the 4th on the top there. So that's good. Like I was saying, right here we don't really need to move these up and down. I can use my quotient rule right away on this, and x to the negative 8 minus negative 12. Well, negative becomes a positive, so I have negative 8 plus 12, which is going to be 4. And that stays in our numerator. I do still move that down, that 3 to the negative 2 down, and get 9 times 16, whatever that is. So we get the same answer there. Let's do another. Oops, I got rid of part of my negative rule there. For some reason that won't erase. I don't know why that won't erase. Let me try that again. Erase. Why don't you erase? Go away. Okay, there, that's gone. Alright, negative rule right there. Anyways, let's say I have 4 x squared y to the negative 3. Let's square that times 2 x cubed y to the 3rd. Okay, so I do want to follow our order of operations. I'm going to do my exponents first. I'm not going to try to multiply these first. So I have 4, see that's going to have an exponent of 1, 1. So 4 squared is 16, x to the 4th, and then y to the negative 6 times 2 to the 3rd, that's going to be 8, x to the 9th, y to the 3rd. And now I don't need to move that y down. I can just use my product rule and multiply. Now whatever 8 times 16 is, we'll have in front, and x to the 4th times x to the 9th is going to be x to the 13th. We add those, and then negative 6 plus 3 is y to the negative 3rd, and then we move that down. So we have 16 times 8, whatever that is, x to the 13th, all over, we move that y down, y cubed on that example. So as a pre-calc student, you're going to have to do more and more of those longer problems where you have to do little steps at a time in order to get our answers. All right, fractions and decimals, not going to spend a lot of time on this. If I have 0.25 and I want to make that, see that's a decimal, I want to make that a fraction. That's going to be 25 over 100. And then I need to reduce that. Well, why do I know that that's 100? Well, I look at my place value. See, this is the ones place. And right here, this is the tenths place. And right here, this last one, that's the hundredths place. So I'm going to go ahead and take this last place. It's 25, see 25 over 100. And then I reduce that. I can divide both top and bottom by 25. To reduce my fraction, get 1/4. I could have something like 0.3. Okay, that's 3/10, so 3/10, and that doesn't reduce. Maybe I have something like 0.004. All right, well, I have, this is tenths, hundredths, thousandths, so this is in the thousandths place, so 4 over 1,000. And then I can reduce that by dividing top and bottom by 4. And I believe we get 1 over 250. Don't take my word for that. I just did that in my head. So 4 divided 4, and then 1,000 divided by 4. Just check that on your calculator, make sure that's correct. So when we're taking a decimal and going to a fraction, we're going to do it by the place value, and we look at that last place value there. Now sometimes we might have something odd or tricky where we might have like 5.12. Well, now what do? I would argue do it the same way. Take a look at this. This is the 100th spot, so my denominator is 100, and I have 512 over 100, and then I can reduce that by dividing by 4. And we get 25 here. I think we get 64 right here. No, I think we get 128. Yeah, we'll go with 128, but check that again on our calculator. And you might want to make that mixed, you might not. If you wanted to make that mixed, you'd do 128 divided by 25. And then you would, well, let's go ahead and do that. 5 times 125, subtract, you get 3. So we have a remainder 3, but we won't write it like that. We'll do 3 over 25. Get that. Now we could get this right away. We could just say, we could just take this part and say we have 5 wholes, and then 12 over 100, and then reduce that, divide both of those by 4, and get the same thing. So either way is fine. Let's do, that's easy. We don't need to do another one. All right, what if I had a fraction? What if I had 12 over 25? And I want to make that a decimal. Well, then I'm going to do 12 divided by 25. Now, if you have a calculator, this is pretty easy. But if you're taking one of those standardized tests where they're checking that you can actually do this, you're going to add your decimal point, you're going to bring it up, and add a 0 here or 2. 25 does not go into 12. 25 does go into 120. In fact, it will go in 4 times. Now, if you don't know, you're going to guess and check. You're going to estimate based upon this place and these places how many times. Now, you might think, well, 6, but this 5 rounds that up to a 3, so about 3 right here. So 3 times 4 is 12, so I'm thinking 4. So 4 times 25, that is 100. Then I subtract, I get 20. Compare, make sure this number is less than that one, bring down my 0. And then looks like 8. And we're good, 0.48. All right, let's try this one. Let's make that a decimal. So top divide bottom. Again, I am going to add a decimal place, and notice I'm doing a few more here. All right, 60 does not go into 13. We'll go into 130, in fact twice. 120, subtract, get 10, bring down, be careful, I'm at that one. Not quite 2, 1 this time, so 60, subtract, we get 40, and then bring down, and then probably, well, not 8, 7's too big, 6, so 360. And then 40, we see that that's going to keep on repeating there. So, repeating, the 6 repeats. Okay, so this is a repeating number. Now notice repeating numbers, and we'll work on this later in the year, but we can change repeating numbers into fractions. But for now, we don't know how to do that, so we're just going to go for the fraction, and that's a repeating decimal. And this is called the terminating. So terminating, and this is a repeating. You could have a neither, in which case it's an irrational number. So let's just end with numbers. We have our natural numbers, or counting, and these are like 1, 2, 3, 4, 5, and so on, just goes on. But we start at 1. We don't count 0 objects. Why? Because there are no objects to count, so it doesn't make sense. And our symbol for that is an N. Then we have our whole numbers, and these are basically the counting numbers plus 0. So we just start at 0. So now we actually count no objects. And we start at 5, goes on to infinity. Notice no negatives, whole numbers, W. And then we have our integers. We will use a z to mean integers. I don't know why we'll use a z, we just will. But our integers are going to be positive and negatives. So we could go from negative like infinity and it goes on. So those are integers c. And then finally we'll just say we have the rationals, which is a q. And that's anything that's a decimal or fraction, basically, for now. All right, you should now be ready for your assignment. Well, what is your assignment? Well, it's going to be the PreCalc section 1. You're going to do numbers 1 to 32 all. Don't worry, most of them are easy. They're mostly that interval notation stuff. And then, I think it is 47, but let me double check. Yeah, 47 to 52 all. 47 to 52 all, that's going to be your rules of exponents, and be very careful on those. If you need help, do get it. All right, that's it. Good luck.